Hi, my name is Tahanin Mana. I'm going to talk about Python 3 programming language. In this presentation, I'll be covering the following topics: Python overview, data types, control structures, input-output, functions, file handling, exception handling, modules, classes, Python versus Java examples, useful tools, and finally, who uses Python. Now let's get started with Python overview. Python is a high-level programming language. It's designed to be highly readable. It uses English keywords frequently, whereas other languages use punctuation. And it has fewer syntactical constructions than other languages. Python is interpreted, so it's processed at runtime by the interpreter. So you don't need to compile your program before executing it. That's actually similar to Perl and PHP. It's interactive. You can use a Python prompt and interact with the interpreter directly to write your programs. Python supports object-oriented technique of programming that encapsulates code within objects. And Python is a great language for the beginner-level programmers, and it also supports the development of a wide range of applications, from simple text processing to www browsers to games. Python was conceptualized by Guido van Rossum in the late 80s. Rossum published the first version of Python code 0.9.0 in February 1991 at the CWI, which is Centrum Wiskunde Informatica, in the Netherlands, Amsterdam. This is called in English the National Research Institute for Mathematics and Computer Science. Python is derived from ABC programming language, which is a general purpose programming language that had been developed at the CWI. Rossum was working in a project at the CWI. It was a distributed operating system developed using ABC. He decided to try to design a simple scripting language that has some of ABC's properties, but without its problems. So he started typing, created a simple virtual machine, a simple parser, and a simple runtime. So finally, he ended up making his own version of the various ABC parts that he liked. Rossum chose the name Python since he was a big fan of Monty Python's Flying Circus. Python is now maintained by a core development team at the Institute, although Rossum still holds a vital role in directing its progress. Actually, his role is reflected in the title given to him by the Python community, which is BDFL, as an acronym for Benevolent Dictator for Life. Python has 3 major versions and several minor versions. The major versions are Python 1, Python 2, and Python 3. Python 1 was released in January 1994, and the major new features included in Python version 1 were the functional programming tools like map, filter, and reduce. 6.5 years later, Python 2 was introduced. This release included list comprehensions and a full garbage collector, and it was supporting Unicode. After 8 years in the versions 2, Python 3 was released. Python 3 is not backwards compatible with Python 2. The emphasis in Python 3 had been on the removal of duplicate programming constructs and modules. Now let's talk about some key changes in Python 3. First, Python 2's print statement has been replaced by the print function. So here, this is the old print statement with Python 2, and here's the new one with Python 3 with parentheses. Actually, Python 2 doesn't have a problem with additional parentheses, but in contrast, Python 3 would raise a syntax error if we called the print function without the parentheses. Second, there is only one integer type left, which is int. And now long is renamed to int as well. Also, some methods such as map and filter return iterator objects now in Python 3, whereas in Python 2, it returns lists. And for those cases where we really need the list objects, we can simply convert the iterator object into a list via the list function. In Python 3, a type error is raised as warning if we try to compare unorderable types. For example, if we try to compare 1 with an empty string or 0 with none, which is a null value, those are no longer valid in Python 3. Python 3 provides Unicode UTF-8 strings, while Python 2 has the ASCII string, str, types, and separate Unicode. It doesn't have the UTF-8. Python 3 now has a string formatting method called format that replaces the %string formatting operator in the old Python. Actually, it's still working in Python 3, but beside that, it has this method. In Python 3, we should enclose the exception argument in parentheses, like this. So this is the old version without parentheses here, while here we need to enclose the exception argument with this parentheses. In Python 3, also we have to use the as keyword in the handling of exceptions, like what you see here. Here we don't have to use the as keyword, while here we need to use it. And the division of two integers returns a float in Python 3 instead of an integer. And this operator can be used to have the old behavior in Python 2, where it returns an integer as a result of division of two integers. Python has a lot of features. It's easy to learn. So Python has few keywords, simple structure, and a clearly defined syntax. This actually allows the student to pick up the language quickly. It's easy to read. Python code actually is more clearly defined and visible to the eyes. Also, Python's source code is fairly easy to maintain. It's portable, so it can run on various hardware platforms and has the same interface on all platforms. It's extendable, so you can add low-level modules to the Python interpreter. These modules enable programmers to add to or customize their tools to be more efficient. It's scalable, so Python provides a good structure and support for large programs. It can be used as a scripting language or can be compiled to bytecode for building large applications. Python also has support for an interactive mode of testing and debugging. It has a broad standard library cross-platform that is compatible on Unix, Windows, and Macintosh. This is a very important feature in Python. Everything in Python is an object. So variables, functions, even code, everything is an object. And every object has an ID, a type, and a value. So as you see here in this example, if we assign 36 to the variable x and use the ID function of x, it will give us this number. And if we use the type function, it will give us the class type of this variable, which is int. Actually, the ID is a unique identifier that identifies a particular instance of an object. Generally, it's like an address. And the type identifies the class of an object, and the type function returns the variable type of whatever inside the parentheses, which is very useful. And more features. Python provides interfaces to all major commercial databases. Python supports functional and structured programming methods as well as object-oriented programming. Python provides very high-level dynamic data types and supports dynamic type checking. Python supports GUI applications. It supports automatic garbage collection, and it can be easily integrated with C, C++, and Java. Let's go to Python syntax. Indentation is a very noticeable feature in Python syntax. It's used in Python to delimit blocks. So Python doesn't use begin end statements or braces to denote statement blocks. And the number of spaces is variable, but all statements within the same block must be indented the same amount. So, as you see here in this example, while here we have different number of spaces, this will give us an error. But try to not mix tabs and spaces for indentation. Try to use one of them, and 4 spaces are traditional in Python. Another thing, the header line for compound statements such as if, while, def, and class, as you see here, should be terminated with a colon. The semicolon is optional at the end of a statement in Python. It's only required if you write multiple statements on a single line. If you want to print to the screen, use the print function, and if you want to read an input from the keyboard, use the input function. For the comments, if you have a single line, use a hash sign to begin your comment. Multiple line comments are slightly different. Simply use 3 single quotes before and after the part you want commented. And Python files have extension .py. Python is dynamically typed, so you don't need to declare variables. And the declaration happens automatically when you assign a value to a variable. So here, if we assign 100 to a variable counter, this means an integer assignment. And here, a floating point assignment. And here we have a string, and this none represents a null value. Variables also can change type simply by assigning them a new value of a different type, like this. So here we have x as an integer variable, and simply we change the variable x from integer to string. And Python allows you to assign a single value to several variables simultaneously. And you can also assign multiple objects to multiple variables, like this. So here, A has a value of 1, B has 2, and C has a string John. Now let's go to Python data types. In Python, numbers are immutable objects that cannot change their values. That means changing the value of any number data type results in a newly allocated object. And there are 3 built-in data types for numbers in Python 3: integer or ints, floats, and complex numbers. Complex numbers consist of a real part and imaginary part, but actually this is not used much in Python programming. The most common number functions are listed in this table: int of x to convert x to an integer value, float of x to convert x to a float number, abs gives the absolute value. To compare two numbers, use comp x and y. This gives the exponential value, this gives the logarithm value, and this gives x to the power of y, and this gives the square root. Strings in Python, like numbers, are immutable objects, so they cannot change their values. For example, when you give str this string and try to change the first letter, that will give you a type error. Str object doesn't support item assignment. So what you can do to update an existing string is reassigning a variable to another string. There is no character type in Python. These are treated as strings of length 1. Python accepts single, double, and triple quotes to denote string literals, so you can use any of them as long as the same type of quote starts and ends the string. And here the triple quotes allows you to have a string that spans several lines, as you see here. String indexes starting at 0 in the beginning of the string and working their way from -1 at the end. For string formatting, use format method that will replace the curly braces here with number 6, as you see. There are some operators for string in Python, as you see here. If you have A string that holds hello and B holds Python, the concatenation operator A plus B will give you this string. The repetition operator, for example here, A times 2 will give this string. The slice operator gives the character from the given index, as you see here. A of 1 will give you E, while A of -1 will give you O. The range slice gives the character from the given range. For example here, 1 to 4 will give you ELL. The way slices work in Python, they don't actually return the last element. So here, the fourth index will not be returned. And N for membership, that checks if a character exists or not in a string. Strings have a lot of methods. This table lists the most common string methods. So count counts how many times this sub occurs in the string, or in a substring if you provide the beginning and ending index. Is alpha checks if all characters are alphanumeric. Is digit checks if string contains only digits. Lower converts the string into lowercase, upper into uppercase. Replace replaces, it will replace this old substring with a new one. Split is a very useful method. It will split the string according to delimiter, and the default value is a white space. Strip will remove all leading and trailing white spaces of string. And finally, title, it returns a title-cased version of string. So all words will begin with uppercase letters and the rest are lowercase. There are also some functions for string, like str to convert text to string, and len that gives the total length of string. A list in Python is an ordered group of elements, and these elements don't have to be of the same type, so you can have numbers, strings, or other lists in the same list. Lists are mutable objects, as opposed to strings and numbers, which are immutable. Elements in the list separated by commas and enclosed within square brackets. The indexes, like strings, starting at 0 and -1 at the end. Also similar to string, list operations include slicing, concatenation, repetition, and membership. Here, this example shows how to access, update, and delete list elements. So here list contains different type of elements. To get the first element, we use list of 0. To get the first or group of elements, we use the slice range of numbers from 1 to 4. So this will bring the first 3 elements. To update an element, use the assignment with the index, and to delete a value, knowing its index, you can use the del statement. But if you want to delete a specific value without knowing its index, you can use the remove method, as you will see later. Lists also can have sublists, and these sublists may contain other sublists as well. This is an example. So to get the first element here, you use 2 indexes, as you can see here. And if you want to get this city, you can use index of 1 and 0, as you can see. Common list functions are the following: comp to compare two lists, len to get the length of the list, max give you the maximum value, min the minimum value, list of tuple converts a tuple into list. And here we have some list methods. Append, to append this object to list. Insert, inserts this object to a given index of the list. Count returns count of how many times this object occurs in this list. And index returns the lowest index that object appears in the list. Remove will remove this object. Reverse will reverse the objects in the list, and sort will sort objects in the list in place. List comprehension is a concise way in Python to create lists. So each list comprehension consists of an expression followed by a for clause. So here, for each x in A, give x to the power of 2. And this is the resulted list. Also, you can use 2 or more list comprehensions in the same line. So here, for this list, apply this expression. And this is the resulted list. Tuples in Python are immutable objects. So once a tuple has been created, you can't add or delete elements from it. So you can say tuple is like a read-only list. The elements in tuples separated by commas like lists, but enclosed in parentheses instead of square brackets. So here, to access the first element, you can give the index, but for assignment, it will raise a type error. So you can't update an element in the tuple since it's a immutable object. As strings, you can update an existing tuple by reassigning a variable to another tuple. Actually, tuples are faster than lists and protect your data against accidental changes to these data. Like strings and like lists, tuples have the same rules for indices, and it has the same operations and functions like lists. To write a tuple containing a single value, you have to include a comma like this. Dictionaries in Python are kind of hash tables, consist of key value pairs, and the elements are unordered. Keys must be immutable data types, and usually they are numbers or strings, while values can be any Python data type. And keys must be unique within a dictionary. Dictionaries are mutable, so they can change their values. They are enclosed by curly braces and items separated by commas, and a colon must be used between key value. Dictionaries' values can be assigned and accessed using square braces with a key to obtain its value. This example shows how to deal with dictionary elements. So, as you see here, we have 3 pairs. This is the key and this is the value. To access a specific value, for example, we have this name, Jude. We use this key to get the name, as you see here. And if you want to list all keys, use .keys method, and here .values to list all values, and .items to list all pairs. As you see here, this is the keys and this is the values, and here is the pairs in a list. To update an existing entry, use an assignment for any key, any existing key, and here to add a new entry simply by adding a new key with its value. So this will add this element to the dictionary. To delete an entry, use its key with del statement. Clear method will remove all entries in the dictionary, and del with the dictionary name will delete the entire dictionary. Common dictionary functions are comp to compare two dictionaries, and len to give the total number of pairs in the dictionary. And here we have some dictionary methods. We've seen keys, values, and items. Get to return the value for a given key, and it returns default if key not in the dictionary. Haskey checks if key in the dictionary or not. And update merges the keys and values of one dictionary into another, and overwrites values of the same key. And clear removes all elements of dictionary. Now let's see Python control structures. First, conditionals. In Python, true and false are Boolean objects of class bool, and they are immutable. And non-zero and null values are considered true in Python, otherwise they are false. And there is no switch or case statements in Python, but we can use if-else statement to simulate switch case. The conditional syntax as follow. For if statement, use this syntax, and you have also if-else statement and if-elif-else statements. And remember to give proper indentation for each block. Example, you can see here, if x less than 0, do this block, else f or elif this, elif this, and else do this. Conditional expression is very convenient and easy to read in Python. So, for example, you can convert this from multiple lines in just one line like this. So here you can say x equals smaller if a is less than b, otherwise give x this value. The for loop in Python is clear and very easy to implement. You have the for keyword and n, and here any variable name, and here the list or string that you want to go through. So in this first example, for each letter in this string, print this letter, as you can see, and here for each element in this list, print this element, and you can also here iterate through the sequence index. As you can see here, len of food, which is 3, range will be between 0 to 2. So for each index from 0 to 2, print this, the food of index. The while loop, here the counter, and here the condition, here your statement, and here you can increment the counter. There are some control statements for loops in Python, like break, continue, and pass. Break ends the loop statement and transfers execution to the statement immediately following the loop. So as you can see here, by reaching letter H, the loop is ended. Continue causes the loop to skip the remaining statements in the current iteration and moves the control back to the for loop. So here, when you reach letter H, the loop will skip H and continue. Pass statement is a null operation. Nothing happens when it executes, like what you see here. Actually, it's useful in place where you have some code but has not been written yet. Python functions. Python functions begin with the keyword def, followed by the function name, then parentheses for your parameters, then a colon. The first statement is optional, which is the documentation string for your function, or doc string. Then here you have the function statements, then the return statement with an optional expression. Function arguments in Python have different types. Required arguments, like here, when you have the arguments that passed to the function in correct positional order. Keyword arguments, when the function call identifies the arguments by the same name as parameters. So in this case, you can change the order of your arguments, and the Python interpreter will match them for you. Here you have default arguments. So age here have value of 35. This is used when the value is not provided in the function call. So here Alex will have the age of 35. Variable length arguments use the asterisk before the variable name in the function declaration, and it's used when you need to process unspecified additional arguments, like here. So in this case, the first function call, arg1 will have number 5, and in the second one, arg1 will take 10, and the remaining arguments will be in this tuple. So this is the output. Now let's see Python file handling. To open a file in Python, use the open function, which creates a file object, and it takes 3 parameters. The first one is file name, which is required, and it takes the file name or the file path. Then the access mode and buffering, and both are optional. We have different access modes. The common ones are W and A, R for reading only, and this is the default one. W for writing, and if the file doesn't exist, it creates a new file. A for appending, and it has the same issue with creating a new file if it doesn't exist. To close a file, use the close method that flushes any unwritten information and closes the file object. Then to read from a file, use the read method, and you can specify how many bytes you want to read from this file. We have 3 different kinds of read. Read to read the whole file at once, readline to read line by line, and readlines to read all lines from the file in a list. Then, to write into a file, use the write method. This will write any string to an open file. Python exception handling. Any error happens during the execution of the code is an exception. And Python has different kinds of exceptions, like name error, that happens when someone tries to access a variable that is not defined. Type error, when you have incompatible data types. Index error, when an index is not found in a sequence. Key error, when the specified key is not found. And exception, which is the base class for all exceptions. The syntax for exception handling: we use try except blocks. So if exception name happens during execution of these statements, then the except clause statement executes. You can catch any exception by using an empty except statement. If we want to have some statements which must be executed under all circumstances, we can use the finally clause. So here, we are making sure by using this final clause that the file object we open must get closed in the finally clause. So after implementing this statement, the zero division error will be raised, and before finishing the try statements, this final clause will be executed. Python modules. A module in Python is any file consisting of Python code, which is functions, classes, variables, and it's a way to organize your code, which makes the code easier to read and to understand. You can use modules by executing an import statement, and you can have one or more modules. From statement lets you import specific attributes from a module into the current namespace. And import start statement can be used to import all names from a module into the current namespace. So now let's move to Python object-oriented. Python provides a well-integrated object model with pretty much all of the tools you accept in an object-oriented language. But actually, nothing forces you to write classes in Python. You can write traditional procedural code just fine. So I'm going to explain Python classes through this example. This is the class keyword, the class name followed by a colon. So this is the class statement which creates a new class definition. Count is a class variable whose value is shared among all instances of this class. It's similar to the static variable in Java. So to access this class variable, you use the class name employee.empCount from inside the class or outside the class. Here the first method is init with double underscore before and after the name is a special method in Python, which is the class constructor that Python calls when you create a new instance of this class. The constructor is optional, so if you don't need it, you don't need to include it. Then you declare the other class methods. Like any other function in Python, with the exception that the first argument to each method is self. Self is a reference to the instantiated object, and you don't need to include it when you call the methods. It's similar to the keyword this in Java and C++. So here, this statement would create the first object of employee class, by using the class name and passing the name and salary as parameters. And here's the second instance of employee class. And to access any attribute or method from this class, you can use the object name with the dot operator, while if you have a class variable, you will use the class name with the dot operator. So here's the output. Python has some useful built-in class functions like getAttr to access this attribute of this object, hasAttr to check if this attribute exists or not in this object, setAttr to set an attribute in this object with this value. If this attribute doesn't exist in the object, then it will be created. And delete to delete this attribute from this object. And here's an example that shows how these functions are used. Now maybe you're wondering, so where's the data hiding? Well, data hiding in Python can be applied easily by naming attributes with a double underscore prefix. So, like this example, in this, by using this underscore as a prefix, those attributes then are not be directly visible to outsiders. So it's similar to use the private keyword for attributes in Java. This example shows how to apply inheritance in Python. So here we have person as the base class, and here student is the derived class from this person. So to identify that this class extends person, we just add person name in parentheses. Here we have the constructor of the derived class, which passes the base class parameter. And to call the constructor of the base class, you use the class name dot init and pass the required parameter. Here we have a method overriding, which has the same name and different implementation between the base and derived class. Here we create an instance of the base class, and here an instance of the derived class. Here we have getDetails method of the person object, while here we have getDetails method of the student object. And this is the output. Now let's see some examples for Python code versus Java. First of all, Java is statically typed, which means all variables have to be explicitly declared. In contrast, Python is dynamically typed, so declaration is not required. Also, Python is an interpreted language with elegant syntax, and that makes it a very good option for scripting and rapid application development in many areas. So, for the Hello World example, in Java, we need to create a class for everything and then put our desired methods inside the class. While in Python, you can simply start writing your code and then run it. So the Hello World in Python, as simple as that. To apply string operations such as split, in Java we need to write these statements, while in Python, just that. For collections, here we have a list of characters, and we add different characters in this list. In Java, we do like this, while in Python, simply like this. This example shows the inheritance in each of Java and Python. Here we have animal class, dog class that extends animal, and we need to include main in Java every time. while in Python, we can apply the same example by this code. While we don't need a constructor for this derived class here, we don't have to call the base class constructor to pass the name parameter. And here, Python interpreter will directly assign this name to the name in the base class. So we can realize easily from these examples that Python code is much shorter and more concise. Let's know some Python useful tools. We have Python IDEs like Vim, Eclipse with PyDiff, Sublime Text, Emacs, Komodo Edit, and PyCharm. And the most common web frameworks for Python are Django, Flask, Pylons, Pyramid, TurboGears, and Web2Py. Finally, who uses Python? In the field of web development, we have Google and Yahoo. Both use Python. So for Google, many components of the Google Spider and search engine are written in Python. And for Yahoo, Yahoo Maps and Yahoo Groups use Python. For games, Battlefield 2 uses Python to implement core elements of the gameplay, such as scorekeeping and team balancing. While Crystal Space 3D uses Python for scripting through a plugin mechanism. For graphics, the Walt Disney feature animation is also using Python to add script ability to their animation production system. The Blender 3D makes use of Python as an extension language. In the science field, the National Weather Service uses Python, and NASA uses Python in its integrated planning system as the standard scripting language. Applied Maths is using Python in their bioinformatics software suite. In the field of software development, we have Nokia, which is using Python to provide high-level programming environment for their platforms. Red Hat Linux distribution uses Python for its installer and configuration utilities. And also IBM uses Python. For education, the University of California, Irvine has developed dozens of Python applications, including a searchable schedule of classes and a real-time class roster retrieval and grade posting system for faculty. SchoolTool also uses Python, which is a project to develop a common global school administration. And finally, for government, the USA Central Intelligence Agency, CIA, is powered by Python. Here is a list of my references, so if you need any more information, you can check them. Thank you for watching, and I hope you have found my presentation useful.